All right, let's take a look at the Fusion Slicer Assembly preset. We will use it to cut a slice through this simple Fusion model. But first, let's hide the Fusion item and its source meshes so that we can get a better look at the slicer when adding it to the scene. It can be found in the Add Item popover under Item Assemblies, MeshFusion Assemblies. There are two versions, the only difference being the number of control points on the slicer's spline. So we'll just double-click the 3-point version to add it to our scene. All of its items can be found in this Fusion Slice 3-point group locator. The origin of our procedural slicing plane is this spline. It actually has 5 points if we count the ends, but we call it the 3-point spline because the center 3 vertices are fully editable using the control handles attached to those 3 center vertices. And here we also see the locator used to position, orient, and scale the entire slicer assembly. Always use this locator to transform the slicer, as opposed to directly transforming the spline or the slice plane. An important note, there is a small glitch in the assembly, and an updated version of the preset is, or soon will be, available on the Modo forums. While the transform locator works fine for translation and scaling, it does not properly rotate the spline, as you see here. There is a simple fix. Go to the Setup tab, select the line, then control-click to also select the locator, and next, in the Modifiers V tab, click the Rotation Constraint button. Now the line remains in sync when we rotate using the Transform locator. Okay, so let's bring back our Fusion item and its source meshes and do some slicing. What we see here is pretty typical. If your Fusion model is centered in 3D space, the slicer will be off-center relative to that model. And that's because the slicer's spline and locator are initially at the 3D origin. So we use the slicer's locator to position and scale the slicer. It's usually best to scale proportionally. However, the locator's x-axis can be used to change the aspect ratio of the slice plane to better fit your model. In this case, the default square shape is fine. There's really no need to worry about centering the slice plane precisely on the model, as long as it covers the portions of the model that you wish to slice, then we're good to go. So adding it as a trim, adding this slice geometry as a trim is just like any other Fusion trim. You would select the primaries that you want to trim, in this case both of them, plus this slicing plane, and hit the Apply as Subtractive Trim button. And there you see it is slicing the geometry. Aside from that locator that we just used and the trimming plane, which is of course a thickened plane to give you some thickness when you perform your slice. Besides those two elements, there are several others that make up the Fusion Slicer assembly, and they're all located inside of this group locator, Fusion Slice 3-point in this case, 3-point group. And we can see them here. Mostly they are just controls. We have some channel handles and the locator that we use to transform the assembly in its entirety. And there is also this line. It's a simple polyline that gets procedurally expanded into our slice plane geometry. Moving the vertices of that polyline transforms that flat plane into other more interesting shapes. Once you have the slicer positioned and scaled the way you would like for your model, like we see here, I find that it's most convenient to turn its visibility off. It makes it easier to select the actual control elements that we will be using. Controlling the shape of the slice, again, is just simply a matter of selecting the slice line and then going to vertices, selecting the vertex that you would like to move and moving it. And obviously you want to move it in this case YZ plane. You don't want to be moving it in the X direction in this case. That wouldn't achieve anything and might create problems. So really we're just reshaping the path of the slice. In addition to controlling the direction or the shape of our spline, we can control the roundness or sharpness of each of these corner points. And that's because, again, this is a B-spline, and the only reason that it's sharp now is because there are, once this is procedurally expanded into that trimming plane, there are actually 3 points around this corner, and they're very tightly grouped at the moment. And we can loosen those up by dragging on this circular channel handle here. Making it sort of completely loose and rounded all the way to pretty tight. And that's true of all of the corner points. And that's a nice thing about the workflow. You can remain in vertex mode to move the points, and the channel handles will still react without changing your component mode, and kind of control everything at once. Additionally, the one other channel handle we have is this one at the top, which controls the thickness of the slice. If for any reason you want to reposition the entire slice, then it's a good idea to go back to the locator. Obviously you want to keep it so it covers the entire geometry that you're slicing, but other than that you're free to move it as desired. One thing that you will need to avoid is creating self-overlapping geometry in this slice plane. And that can occur when the slice is thick and the curvature at any of the corner points is tight. So if I thicken this up, you see at some point it starts to fail. And that's because, we make this visible again, the inner part of this surface on the inside of the curve will begin to self-intersect once that gap is wide enough and the curvature is sharp enough. So that's just one thing to watch out for. It's pretty forgiving, and since most of the time I imagine this will be used to create fairly narrow slices, I don't anticipate it being much of a problem. But if you do see the fusion mesh breaking, it could well be due to a combination of a tight corner and a broad slice. Please keep an eye out for additional Fusion Slicer videos coming soon.